Good morning. In today's class we will learn about bar magnet and some of the properties of bar magnet and its magnetic field. Till now we have learned about the magnetic effects of current. That is, when a current flows through a conductor, it produces a magnetic field, and we learned how to find out the strength of that magnetic field and also how to find out the direction of that magnetic field. Now and also we learned that a solenoid, when a current flows through the solenoid, it behaves as a magnet with one side as north pole, other side as south pole. Now in this class we will learn about actual magnet, the bar magnet, not a solenoid but a magnet. We can call a bar magnet as a natural dipole. A bar magnet, we can call it as a natural dipole. That is with two poles. One is called north pole, another one is called south pole. A bar magnet can be called as a natural dipole, and this dipole will produce a magnetic field. Now we will first learn what are the properties of this magnetic field. Properties of bar magnets. First one, the ends of bar magnet. Like if I draw a bar magnet something like this, so this can be called as, one side is north pole, other side can be called as south pole. Now here the ends of the magnet where the force due to this or the magnetic force is maximum is called as poles of the magnet. Now the two ends where the force or the magnetic force is maximum is called as the poles of the bar magnet. The ends of bar magnet where the magnetic force due to bar magnet is maximum. Where the magnetic force is maximum are called poles of the bar magnet. The ends of bar magnet where the magnetic force is maximum are called poles. Now these poles can be named as north pole and south pole, but how do we name them? A freely suspended bar magnet aligns itself in the north-south direction of Earth. A freely suspended bar magnet aligns itself in the north-south direction of Earth. The pole which is towards the north direction of the Earth is called as north pole, and the pole that points towards the south of the Earth is called as south pole. This is how actually we name them as north pole and south pole. You have to freely suspended a bar magnet and you have to check like which side points towards which direction. So pole of a freely suspended magnet, pole of a freely suspended magnet which points towards the north of Earth, which points towards the north direction of Earth, or I can say simply north of Earth, is called north pole. Or we simply denoted it by N. And pole that points towards south of the Earth. Pole that points towards south of the Earth is called south pole. Or we simply denoted it by N. And pole that points towards south of the Earth is called north pole. Or we simply denoted it by N. And pole that points towards south of the Earth is called south pole. is called south pole or S of bar magnet. A freely suspended bar magnet aligns itself in the north-south direction of Earth. Pole of a freely suspended magnet which points towards the north of Earth is called North Pole, and the pole which points towards the south is called as South Pole of bar magnet. Now the next property is like poles repel each other and unlike poles attract each other. Like poles repel each other and unlike poles attract each other. And another important property is the magnetic poles always exist in pairs. Like you will not get just a south pole or just a north pole. It always exists in pairs. Magnetic poles always exist in pairs. Every bar magnet is a magnetic dipole. There is no single pole magnet. Monopoles do not exist in magnetism. So remember, monopole does not exist in magnetism. Now next we will see some of the definitions, like what is pole strength, what is magnetic dipole moment, and what is magnetic length. For that case we will consider a magnet, and let us mark points, two poles, as one is south pole, the other one is north pole. Now so just to mark it, I'll just take like this, north pole and south pole. Now let's also mark this pole strength as the length of this magnet is called magnetic length. So I'll mark that. Let me mark this, sorry, total distance as 2L. And this is magnetic moment M. Let it be like that. So we'll define few quantities. One is pole strength, and then magnetic length, and the last one is magnetic dipole moment. First, pole strength. The pole strength of a bar magnet is denoted by M. So in simply, magnetic dipole is an arrangement of two magnetic poles of equal and opposite strength separated by small distance. So I can call this as a magnetic dipole. So it's an arrangement of two magnetic poles. So next I'll write what is magnetic dipole. Magnetic dipole is an arrangement of two magnetic poles of equal and opposite strength equal and opposite strengths. separated by small distance. In this case I have shown that distance as 2L. Now as I said, the opposite, sorry, here there is a spelling mistake here again. Opposite okay, so opposite strengths. Magnetic dipole is an arrangement of two magnetic poles of equal and opposite strength separated by small distance. Now here we will take the pole strength as m. So generally it is denoted by small m. The pole strength of a bar magnet is denoted by small m. The pole strength of a bar magnet is denoted by small m, and its SI unit is, it's a scalar quantity, remember. It's a scalar quantity and its unit is ampere meter. Ampere meter. The pole strength is denoted by small m and its unit is ampere meter. Next we will see what is magnetic length. What is magnetic length? That in the figure you can see it is denoted by 2L. Magnetic length. So this can be defined as the distance between two poles of a bar magnet. The distance between two poles of a bar magnet. As in the previous figure I showed it by 2L. The distance between the two poles of a bar magnet is known as magnetic length. It is denoted by 2L. 2L. And the magnetic length is a vector quantity and it is directed from south pole to north pole of a bar magnet. So it is measured in meters. Meters, or SI unit is meter. Next is the important thing, that is magnetic dipole moment. Magnetic dipole moment. The product of the pole strength of either pole, the product of the pole strength of any one pole and the magnetic length of the magnet is called as magnetic dipole moment. Pole strength. The product of pole strength of any one pole, because both are of equal pole strength. The product of pole strength and the magnetic length. The product of pole strength and the magnetic length is called magnetic dipole moment. Of the magnet is called magnetic dipole moment. So generally it is denoted by capital M. It is denoted by it is denoted by M. So it's given by M as M dot to L. It's a vector quantity and is directed from south pole to north pole of a bar magnet. The dipole moment is a vector quantity. it's a vector quantity and is directed from south pole to north pole of a bar magnet. Bar magnet. Its unit is ampere meter square. It is measured in ampere meter square, because we know the pole strength is measured in ampere meter and 2L the unit is meter, so you get ampere meter square. The product of pole strength and the magnetic length is known as magnetic dipole moment, and it is measured in ampere meter square, because pole strength is measured in ampere meter and the magnetic length in meter. So the SI unit of magnetic dipole moment, you will get it as ampere meter square, and it is a vector quantity.